we're going to factor this polynomial in order to find the roots, and then we're going to graph by hand. So the first thing we're going to do is factor out a GCF of x, which would give us x squared minus 4x plus 4. And now we can factor this inside part to x minus 2, which gives us our zeros of 0, 2, and 2. So 0 has a multiplicity of 1, and 2 has a multiplicity of 2. It shows up 2 times. So we know that multiplicity affects the graph by if it's an even multiplicity, it will bounce. And if it's an odd multiplicity, it will go through. So our graph is going to go through at 0, and it's going to bounce at 2. And we need to look at the end behavior also. So here the end behavior would be opposite directions, and it's positive, so it's going to be down and up. So our graph is going to start down and end up. And then we know our zeros are at 0 and 2. So at 0, we're going to have a point, and at 2, we're going to have a point. And now we're kind of going to do connect the dots. So we're going to connect the end behavior to the zeros, and we're going to use these multiplicities. So it's going to start down, and then it's going to go through at 0. Then at some point we're going to have to turn back around to come down to 2. And at 2, it's going to bounce. So the graph will hit the graph at 2 and then bounce back up, and then there's no more zeros, so we would connect to the end behavior. So it's kind of like connect the dots once you get to this. You can also find relative maxes and relative mins and plug those in for a more accurate graph, but for the most part we just want to sketch. A relative max and relative min you will learn next video. And we look at the graph, and it is pretty accurate. We have the right end behavior, then the right zeros, and here you can see it goes through, here it bounces, just like our graph.